welcome to this.
Thank you, Jay.
So, let's check. Solid. Good. So today our lesson is on. Let me do this one. Okay, my keyboard is working. Okay, so let's continue. So we are doing higher derivatives, right?
Okay.
So let's go to our source material. Now we have seen that um, y is a function of x. Y is a function of x. Then the y with the x will also be a function of x. The result of differentiating the y dx with respect to x, called the second derivative. I'm taking it again. In simple terms, if I say y differentiating one function, if you give you y, you found the y dx. When you differentiate the new function, that becomes a higher derivative. So it is denoted by d square y over the x squared, right? If the second derivative is also differentiated with respect to x, the third derivative will be d cube y over the x cube, right? It's obtained and so on. Note that d square y over the x squared is the same as differential of dy dx. So you see, when you differentiate a dy dx, the d will be what? Squared, and the x over here to be squared. Another way of writing it is using the function. You see, if you have f at x as a function, the first derivative is prime, the second is prime prime, and so on and so forth. For example,
Okay.
you have a function like y equals 2 squared plus 1, right? Y prime.
Okay.
Y prime is the same as what? Dy dx will become what? 4x. Right? You let me give this function like a much more complex function. Right? So if you differentiate for the first time, it becomes what? 6x squared
6x squared plus 8x
plus 2.
2.
When you differentiate for the second time, that is what we call d squared of y over the x
Okay.
squared. Right? You are squaring the d at the top, you are squaring the x below.
Okay.
Because the explanation is that if this expression, it can be written as what? Dy dx. Right?
Okay.
And now we are going to differentiate. You see on a calculator, you see that differentiating the box dx,
Okay.
which is differentiating the differential with respect to x of a certain function. So now in this case, if the function 2 is a dy dx function, right, what are we doing? At the top, the d is multiplying d, giving you d squared of y. And the down one is the what? The x squared. Meaning everything down there, no? Like something like this, right?
Okay.
But when they write it, they don't write this thing. The focus is that you are differentiating the x element for 2 times.
Okay.
Hmm. But yeah, the second derivative will be what? Just the differentiate this one, giving you 8x plus, no, did I say 8? 12x,
12.
12x plus 8, right? If I want to do the third derivative, which is going to be what? D cubed
12.
y over dx cubed. What will be the answer?
12.
12. And easy does it. Very simple. So let's take some
Okay.
examples. Now in this function, they say find dy dx d square y over the first derivative, the second and the third derivative. So 3x
Okay.
exponent 4. Find of y equals 3x exponent 4, 2x cubed, 2 over x, right? So yeah, the first one, dy dx, becomes what?
Become 12x cube plus
Plus
6x squared minus 4x exponent negative 3.
you see, I know the shabro. You wait for your head inside. Oh, he. The second one becomes what?
Becomes let me use my calculator for
3 times 12 na go use calculator. Faster.
36x squared plus 12x plus 12x exponent negative 4.
Very good. And let's find the third one.
72x plus 12
Mm.
minus 48 x exponent negative 5.
Very good. But you can send it back to the fraction for them so that it becomes x over
X over 5.
x plus.
48 over x exponent 5.
Okay, so that's quite impressive.
Yes.
I think this is okay, and you can do all the questions over there.
Oh, yes.
Now it says that given this, find this and state the values of x for which x for no, given this function, find the second derivative and state the values of x for which this second differential is equal to 0. So where they are come to apply some quadratic elements or what. Yeah, but we've also been able to cover calculus for this calculus is plenty, it entails a lot. You've done well.
Yeah.
If you understand the algebra there, then The applications will not be difficult for you.
Okay.
But differentiation, integration has much more techniques. I'll see maybe if I'll take you through the integration techniques.
Okay.
Let's see. Let's find the dy dx. If I'm writing the dy dx, it's plenty. Let me write y prime. 4x cubed minus 3x squared plus 4. Right. The second y prime becomes 12x squared minus 6x. Right. When you differentiate the constant, what do you get? 0.
Yes.
So now it says that when this is equal to what? 0. Right. As in
Okay.
the second derivative. So it means equate this to 0. Over here, what can we factorize out? You can factorize x,
8,
you can factorize 6.
6.
So it's
Yes.
x minus 1 equals 0. That means 6x equals 0. 2x plus 1 is also equal to 0. X equals
Mm.
0. X equals half.
Yes.
Yes. So x equals 0, x equals half. This is
Mm.
set. This is state the set of values. So set of values. Now whenever they say set, you use the curly bracket. So x is such that x equals 0 or x equals half. Are you okay?
Yes, sir.
So that's what it is. Meaning when you put 0 there, that function becomes 0. When you put half to it, it becomes 0. Now there are some useful information here. Where is it come from? Ah, wait to okay, we are doing higher derivative. Okay.
Yes.
So now let's do implicit function. So the higher derivatives, you will be applying it in application of differentiation. Most of the time, we apply it in quadratics when you are finding gradients, and also when you are finding acceleration, velocity, displacement, those stuffs, and also
Um,
points of inflection. Okay, so implicit function. What do you mean the word implicit? It even sounds like accomplished.
mm.
It means like a kind of they are together.
Okay.
Okay, I'm coming. Now, an implicit function is two variables in two variables x and y. Say it's one which is neither variable a which neither variable can be easily expressed in terms of the other. For example, equation x cubed plus y cubed equals 3xy. It's an implicit function since y cannot be easily isolated on one side of the equation. To differentiate this implicit function, what do we do? Differentiate it term by term to give an equation in dy dx. and x and y. Make the y dx the subject of the equation. It is useful to
Okay.
understand that whenever you differentiate y function, anything that has y in it, you have to attach the y dx. So for example, if you are differentiating y, the derivative of y will become what? 2y. No, the derivative of y will become dy dx, but the derivative of y will become 2y dy dx.
Okay.
The derivative of 2y cube will become 6y squared dy dx. So when you differentiate the y function, write the answer and attach the dy dx to it. That's the rule.
Okay.
Now treat terms such as 3xy, xy squared, etc. as products and use the product rule. And also treat terms like y over x squared or 2y over x as quotient rule. Right? So let's start with the equation of a circle. Its radius is 0. This one is more of a point. So x squared plus y squared equals 0. X squared plus y squared equals 0. Divide the x. My pen is blue. So solution, x squared plus y squared equals 0. When you differentiate x squared, you are getting 2x plus, when you differentiate 2y, what would you get? 2y. But you attach the y dx to it. Okay. Then what happens? You make the y dx the subject. You make the y dx the subject. So over here, 2y divided becomes negative 2x, right? So dy dx become negative 2x over negative 2y. This and this cancel.
Okay.
Dy dx x over y.
Okay.
Okay.
Okay. Please that go.
Come again.
Please that all.
Yeah, that's all. So differentiate them like normal differentiation. But when you are differentiating a y function, you attach the y dx to it, to that answer. Then
Okay.
after that, group all the dy dx to one side and make that dy dx the subject.
Okay.
My app is pulling. I don't know why. Come here. What is it again? Oh my god. The vectors, how far? You still the more.
Yeah, now they go then. Yeah, this the question we did the book inside self. I do the Nigeria one. I do the vectors.
Oh, nice.
That one cry in that one hard.
What is it about?
The first one is about the equilibrium something that you are talking about.
Uh-huh.
Then the second one is about parallelogram. But in the question, they will not tell you it's parallelogram. But if you see the way the question is, you have to know it's a parallelogram.
Okay. Yeah, the
Yeah.
heat.
Then they will ask you to find this one. Yeah, the unit vector. That's the II.
The vector by its magnitude.
Yes.
So today, this morning, the app is slow. Don't know why.
And they just want to add it. What's the name? Question the 11 II. The the fx that root of 16 minus x squared over x squared plus 4. And they ask him to find the domain of the x and the
Yes.
f.
Yes.
Yes. I think
Oh,
that one, instead of you using denominator. Now you have to use
The
the
numerator.
numerator rather.
Yes.
It was the numerator rather. So I did that one. Then I had negative 4, 4.
Okay. That's good. Did you get some resource material to help you? Maybe online material. My app is messing up.
I was doing some combination of books.
Okay. Yeah, you are doing
Then I tried some of the question too. When you tried this one, Google is giving some plenty things. So that one, once I come score, then you solve that one.
you are using
Like the combinations, then some of the other things.
my app is running slow. I don't know why. Maybe I don't have data or what. I don't know.
Um,
If I use this thing too, it will not connect. I don't know why it's behaving like this. Let me search on the internet. I don't know why it's delaying me. Maybe you have to use Microsoft OneNote.
um,
Okay, let me use OneNote for the meantime. As I wait for this one to open.
um,
Okay, so implicit functions. Let's see if I can get. I don't know why today is delaying. It's delaying too much. When is this? So 2x squared minus 3xy. X squared minus 3xy plus
okay.
6y squared equals 15. Right? Find
Okay.
y. What are you finding? Y dx. So this becomes 2x minus. Now over here is a product function. Because of the product function, it treats them as two different products. Do you remember the product rule?
Yeah.
So you take one, attach the other one. So now let's differentiate the 3x. You get 3, then you attach y.
Okay.
This way, plus, you don't do anything to the 3x, but you differentiate y. Now when you differentiate y, what do you get? You get 1. The exponent here
One.
is 1. So 1 times y will be 1y. 1 minus 1 will be 0. So you get 1, right? 1, then you attach the y dx to it,
Okay.
right? Plus 6x squared, the 6x squared.
6y squared.
Yes, 6y squared. So it becomes 12y dy dx
Yes.
equals to 0. When you differentiate a constant, you get 0.
Okay.
Don't know why I don't know what it means. I slow too much. I want all the notes to be on one side so that if I'm sharing, I'll do it later. Now let's look at this. This becomes the solution. So 2x minus 3y. So you see the way I treated a negative, so that it will not, I will not miss it.
Okay.
So minus 3x dy dx plus 12y dy dx equals 0. Now make dy dx a subject. So let's move all the dy dx to one side. As negative 3x, you can refactorize them plus 12y bracket dy dx
Okay.
equals to 3y minus 2x over here. Let's move all of them to the other side.
Okay.
So it becomes dy dx equals 3y minus 2x all over negative 3x plus 12y. Now we've been able to separate them, and the dy dx is standing alone. Right, so this becomes the final answer. If we can factorize something out, I don't know. I think it's okay. Are you okay? So let's do another one.
Okay.
X cubed plus y cubed equals 3xy. X cubed plus y cubed equals 3xy equals 3xy. Find y dx. In this case, this becomes, now let's do this one so that I'll write.
You have 3x squared
I want to separate this. 3x squared
plus
plus
3y dy
no,
dx.
3y squared
3y squared dy dx is equal to
now here's a product function, so you have to separate them. One here,
3
another one here. So that writes 3
3 okay 3 plus y.
no, it's not 3 plus y. In product function, okay, step by step, you do 3x, you differentiate it like this, attach the y
Okay.
plus 3x, you don't do anything, you differentiate the y, you get it. Are you okay?
Yes, sir.
So let's create this part. 3x squared plus 3y squared dy dx equals, when you differentiate 3, what will you get? 3x, what will you get?
You get 3
3, then you attach the y
y
plus,
plus
you don't do anything to the 3x, but you differentiate the y. When you differentiate,
yes.
what do you get?
You get 1
1. Then you
dy
attach what?
dx.
Dy dx.
Okay.
Now group like things. So that's 3x squared. This and this are similar. This
Okay.
and this are like terms, right?
Okay.
And these two are also the ones with the dy dx.
Okay.
So yellow one side. Yellow,
Minus.
very good. So minus 3y
Yes.
equals to
Equal to
the existing one,
3x.
3y, 3x dy dx.
Yes. Divide the x minus 3y square. Divide the x.
Very good. Now you can factorize. Over here 3x
X
minus y equals over here 3x
x
minus 3y
minus y
squared.
squared in brackets. Divide the x. Divide both sides by 3x
Over
minus
here,
3y squared.
right, over here, we can factorize. The x will come here. The 3 will be out. I think they are even the same thing. No?
Yes.
So basically they cross out each other. So 1 was dy dx. Or let me do the let me do the normal ones that maybe everybody will understand. So 3x squared minus y divided by now they are not the same. You see, if I had rush,
One is squared and one is not squared. Both sides of x and y
it's only the 3 that cancels.
cancels. So there with
So
x squared minus y
that's y over
over x minus
x squared.
y squared. Divide the x. Yes.
So these things they didn't teach you in school. I wahala for you.
They never taught me anything. So we before we writing this one then we were doing our own Takashel Geshi. Then some source B. They used to write. But the source everything came pepe.
It's okay, YouTube.
Ah,
Atasa. Yes, you. You must be a challenge. That one class too. Minus no pass. That's so. Okay, let's go and choose more questions here and
okay.
see. Let's do this one. 3x squared minus 7y squared. When we draw line now, and to me straight. And then how you so 3x squared minus 7y squared plus 4x y minus 8 equals 0. So 1 equals or divided. So this becomes 6x, right?
It's
So say so that right.
minus 14 minus 14 y plus
No, you are doing y. What do you attach? You attach divide
is
dx.
okay divide the x plus
Product rule.
product to that's 4x prime plus
No, it's not plus. Together.
Together is y
Mm-hmm.
plus 4x y prime
Mm-hmm.
minus 8x. No, 8 is 8 is equal to 0.
Very good, very good. So let's simplify.
So we get 6x minus plus 4y divide the x.
No, you are not differentiating the y.
Okay. And by differentiating, okay, plus 4 4x plus
What plus again? You are just attaching. If you differentiate
okay
y,
divide the
yes, if you differentiate y, you get 1. But
1.
basically, if you differentiate y, you get dy dx
Yes, divide the x
minus 8.
minus 8.
Now,
So
look at something.
we
Whenever
suppose
you
it's
have y equals maybe 3x squared or something, and if you find dy dx, you are differentiating y with respect to x, right? So you see that this y will tend to dy dx.
okay.
You get it? Hello?
Yes, sir.
What's the who differentiating y? You don't just write y,
Yes.
but it tends to dy dx.
Okay.
And this one becomes 6x. This means that whenever you are differentiating a y function, you attach the y dx. When you are differentiating the x function, you don't attach anything.
Oh, okay.
You get it? So if it is y
Yes.
squared equals 3x squared, you differentiate y, which is what? 2y. Then you
2y
attach the y dx,
divide the x is equal to
6
6x squared. 6x. Okay.
y cubed equals something, 4x plus 5. It becomes 3y
Y
squared. Then you attach the y dx.
squared divide the x.
What? X exponent 4.
Okay.
Right. So anytime you differentiate y, you get the y dx. Unless it's more, then
Okay. Thank you.
far away. So now let's simplify. Which ones are similar? This and this
Okay.
and this and this and this one too is with the down part.
Another
So we can move the down part
okay.
to the other side. So now we have negative
Okay.
14y plus 4x dy dx. Those are the ones with dy dx. Then we move 8 to be positive 8. Negative 6x, negative 4y. Are you okay?
Okay.
Now let's move this one too. So dy dx becomes 8 minus 6x minus 4y all over negative 14y. Or better, you can rearrange it 4x minus 14y.
Mm-hmm.
We can do some factorization here. 2 is common to all, right? So 2 comes out
Yes.
4 minus 3
4 and 3
y.
minus 2.
The down one to 2 can come out 2x minus
Mm.
7y dy dx
4 minus
3x.
3x minus 2y.
Let's check the solution. Yes, 4 minus 3x minus 2y over 2x minus 7y. That's impressive. Now, let's go to a little bit of the applications. It says that
Okay.
say that x squared minus 3xy plus 2y squared minus 2x plus 4 to increase the weight of this. Right. So find the value of dy dx at point this. Meaning when you find a dy dx, then x becomes 1, y becomes negative 1.
Okay.
So now let's differentiate this one. What do you get?
X. Yeah, 2x
2x
minus
hey, I have a class here. 7 o'clock.
um,
Okay, let me finish this one. Then go. 2x minus what?
minus 3x prime y plus 3x.
Make sure that because we are doing negative here, it's a product function. Put it in this bracket.
Okay.
3x
Y prime plus bracket plus 4x 4y dy dx minus 2 minus 4. Okay, 0.
constant.
Constant 0.
Let me do this one. I'm in a hurry.
Okay.
3y plus 3x divided equals to. I'm moving the 2 to the other side.
Okay.
So 2x minus 3y minus 3x divided plus 4y divided dx. This and this are related. So you let them stand alone. Then move this over to the other side. So
Okay.
if 3x plus 4y becomes a factor, dy dx here 2 minus 2x plus 3y. So dy dx 2 minus 2x plus 3y all over negative 3x plus 4y. That becomes the answer. Where is the answer? Where's the question, bro? Where did I get the question from? Now, at point, this is something. At point 1, negative 1. So when x at 1, negative 1, x equals 1, y equals negative 1, what happens? dy dx becomes 2 minus 2 plus 3 negative 1 over negative 3 1 plus 4 negative 1. The rest is calculator. 2 minus 2 minus 3, 3 minus 4. Yes, 3 over 7.
Okay.
Oh, you can make screenshots.
Okay. Then I'll let you do all screenshot too. Because the one we did the first time, I didn't do screenshots. The first ones.
Okay, I'll show you. I'll open it for you. Check it out. This app is becoming slow nowadays. You don't worry, you can get a YouTube video and go and do the screenshots there.
Okay, I've heard this.
I think I get it. It's here. It's here.
I think we start from where the red lines.
It's true. My man. Okay, so make the screenshots.
Okay, I've done that.
Okay. I'm scrolling up, but it's not moving.
Mhm.
Done.
Okay, I've done S. I've done the side.
So it means the other ones would have been written. It couldn't synchronize it.
Mhm.
Okay, then do the last one.
Okay,
I think I have it bigger here. Do it again.
okay, I've done that.
Okay, Charlie. So you
Okay, thank you, sir. Okay,
go to school. Check the time that I give to you.
okay,
Okay, Charlie, take care.
you can say
Okay, bye.
bye.